The very worst case for streaming in Cyberpunk is you're driving and having a conversation at the same time. Because it means you're driving through the world. It means that you're streaming the textures in. But worse than the textures not streaming in, if the physics doesn't stream in, you'll fall through the world. If the gameplay doesn't stream in, then anything can start breaking. And streaming is one of those cases where when it goes wrong, it just falls off a cliff, and anything can happen at that point.
Right.
It could be T-posers, it could be blob faces, it could be the game crashing, it could be getting stuck in some infinite loop, or who knows? All bets are off if this goes too much to pot.
Welcome to In Development, where we explore the technical realities of creating today's most ambitious digital experiences through conversations with the problem solvers who build, maintain, and optimize the tools, pipelines, and workflows behind games, animation, VFX, real-time visualization, and more. Each episode features in-depth discussions with technical directors, pipeline specialists, and digital creators who share their approaches to overcoming real-life production challenges. Not just what they accomplished, but what went wrong along the way, and how they approached solving those problems. My favorite part of this job is getting to learn from so many amazing creators and to share my own knowledge with others. I learned so much from my guests on every episode, and I hope that you do too. And with that, I am so excited to get into this episode with Colin Walder from CD PROJEKT RED. I met Colin when he was a panelist on a panel discussion at the Game Developer Conference 2025 that I moderated. And he just had so many great stories and so much passion for what he does at CD PROJEKT RED, from his background in audio to working on pipeline tools for the whole dev services division within CD PROJEKT RED. I'm sure many of us have seen the tech demos and trailers for The Witcher 4, which should be coming out soon. They've been working with Epic Games to add features into Unreal Engine specifically for The Witcher 4, and then sharing that so that others can use them as well. And over the years, they've had to build a lot of special tools to overcome the challenges that come with creating such large open world games like what CD PROJEKT RED is known for. In today's discussion, we're getting into managing assets for audio as well as performance and streaming when it comes to games. I think that there's a lot here for everybody, and especially if you're interested in the audio behind some of the games, definitely stick around for this episode. And with that, I'm excited to get into the interview with Colin. So, Colin, thank you so much for joining me today.
Hey, my pleasure.
Can you tell us a little bit about what it is that you do at CD PROJEKT RED, and also maybe what you did at the time when we're talking about this? Because I know your position's changed a little bit.
Yeah, exactly. Currently, I'm one of the engineering directors at CD PROJEKT, and I'm responsible for what's called shared dev services. So this is a few of the tech teams who are working across multiple games, and that includes the audio, the localization, the DevOps, and the asset pipelines. And we want to build some tech that's going to be foundation for all of our games. But my history is most strongly in the audio aspect. So this is where I started in the industry as an audio programmer back in 2006. And then, through my entire career, I've been working on audio programming. So I still have a lot of love for that. And even I do a bit of composing on the side now as my side projects.
Nice. My original interest was composing as well. Like, that was my degree, and then I kind of shifted from there into visual effects and programming. So I think maybe we share a love for audio stuff.
Absolutely. I think you have even the more musical room than me. I mean, I've got a couple of instruments lying around, but yours is pretty impressive.
Thanks. So to start out, I'm curious, what is the tool set that you use? And I guess for that question, maybe focus more on the audio side, because I'm curious, what is a modern day tool set for an audio department on a game?
Sure. So it's quite a diverse group that we have. We think about the whole pipeline for audio. So from the point that we record it to getting in, it's going to involve a whole chain of people. So on the one end, we have our content creators. So this will be our composers and our sound designers. And actually, it can be quite varied. So they will do everything from recording the sounds to then designing them. Yeah. So this is one of the recorders, my personal recorder Mix Pre 6 that I used to record some of the ambisonics. So I borrowed a Soundfield microphone from Sennheiser on one of my many trips to Japan and recorded a whole bunch of sounds that we then processed and put into the game. So this would be the first stop, yeah, something like this, various different recorders, maybe a Sony PCM, which I don't know, I have that lying around somewhere. And then we'll take those recordings for the sound design into a software called Reaper. So this is a very popular digital audio workstation in games. It's quite well suited for the kind of challenges that we face. So when you're working with many different files, making many different versions of those assets, and you need to export them, like do batch exports and custom names, it's very handy for those things, as well as being quite flexible to be adapted. So a lot of our sound designers, they're creating their own scripts, their own processes for how to speed up the workflows. So they'll design the sounds in there. And then we take the sounds into a software that's called Wise, or WWise actually. Usually we pronounce it Wise for short, but the full name is WWise. Right. And this is a software that we use to orchestrate the interactive flow of the audio. So you can take those recordings, you can take those sounds, and it still has some similarities with, let's say, the digital audio workstation paradigm, but it lets you arrange those into containers and say, okay, when this event happens, I want to, for example, trigger a random sound, or I want to trigger a sequence of sounds, or I want to blend between some sounds based on some parameters. So it's really the point where we can start to tie in some idea of interactivity that's coming from the game with those audio assets. For the composers, similarly, actually, their stuff will end up in Wise. So there's an interactive music system in Wise where they can design, okay, when this happens in the game, when some trigger happens, transition from this piece of music to this piece of music, or maybe blend some stems. The composers mostly are working in Logic. So this is a Mac-based digital audio workstation which has some great features for composing especially. So they all both come from either Reaper or Logic, bringing assets into Wise, and then this is where we create the interactive bed. And then from Wise, this is where it starts to enter our toolchain, our pipeline for having it in the game. So we build what we call sound banks. This is the output of Wise, the thing that we can load in the game that says, okay, here's the wave data, here are the audio assets, plus some data to say how they need to be played. And then this is where it starts to transition a little bit into what we call technical sound design, or also onto the code side, onto the audio programming side. So once we have the assets from Wise, they will need to be implemented in the game. So we have to hook up these things. When something happens in the game, someone shoots a gun, or a footstep happens, or a scene starts, then there needs to be some connection that says, this is the point in the game, trigger this event, or set this parameter in Wise that will control the behavior. It might be done by the sound designers, it might be done by the audio coders, or it might be done by a technical sound designer. So actually this is a fairly new role for us, but you see sometimes in different places in the industry, someone who's mostly focused on this kind of interaction between the middleware, Wise side, and the engine. And so the tools that we're looking at with Witcher 4 and Cyberpunk 2 and the following games, this is Unreal Engine, is the editor, the pipeline where these things will be hooked up. Previously, when we think about Cyberpunk, if we think about Witcher 3, then this is Red Engine 4, Red Engine 3, respectively, which have some similar kind of tools and pipelines. Yeah, there's an editor, and in that editor, you maybe have some timelines that you can tag things, or on the entity, you can set different properties. And of course, this whole section now we're touching the editor, now starting to look at the game. This really is also the domain of where we work from the audio programming side. So we will be using a lot of Visual Studio, sometimes Rider, to work in C++, and doing things as varied as, we need to build the pipeline that will import those sound banks. We're doing the work that will do the streaming at runtime, but also building workflows and tools for the sound designers so they can set things up in the editor, or sometimes creating procedural systems. So for example, in the Witcher 4 tech demo, which we showed at Unreal Fest, this is using procedural footsteps. So all of the footsteps, I think, apart from the Manticore, which is like a custom scene, but all of the rest of the footsteps, including the Kelpie, the horse, and all of the NPCs and the Siri, these are being procedurally driven. So this is taking a huge weight off the sound designers, where previously they would need to go through the timeline on the animation and say footstep here, footstep here, footstep here. It's not creative work, not very creative work at least, most of the time. Maybe except in the scenes, but when we think about gameplay animation, or the vast majority, it's not creative work. It's just time consuming and vulnerable to, the animation's got changed, we now need to go through and retag anything. Right. So it was a huge pain point on previous games, especially Witcher 3. Cyberpunk, we did have some, let's say, partial automation, but we have on Witcher 4 the much more thorough procedural footsteps, or building some procedural systems in the ambience as well, working with the sound designers. And we do work very closely with them. So every sprint, some of the sound designers who are working most closely with the technology that we're building in this 3 weeks, they will actually come and join the code team. So they will sit in on the meetings, they will take part, they will be giving feedback, they will be having this very close loop of working with them to make sure that we're delivering the technology that we really will help them there.
Yeah, that's something I was curious about, is kind of how that handoff goes. So it sounds like for you, having them be very closely involved. How much does it go from a creative sense of, we want these sorts of sounds, let's go get those, put them in Wise, package them up, and then now we need to program hooks for them? And how often is it the other side, where it's like, hey, you know what, this thing happens in the game, it'd be great to hook that to a sound, can you get that? Like, how much does it go one way or the other?
Yeah, of course, both parts are happening. The majority for audio often is something that is driven by the rest of the game. So we're often thought of what's called like a post team, meaning that the game is there and then we will be checking the game. We'll do maybe what we call spotting sessions, which is where you look at the game or the designs and you say, okay, we think it will need sounds for this, this and this. So a great example of this would be routine stuff. If we know that the player can wear different types of clothes, then we will want to design sounds for those different types of clothes. If there's a scene and something is happening in a scene, then we'll say, okay, what's happening in the scene? Because we will need to put some stuff in there. Or we're going into combat, okay, we need to change the mood because it's going into combat. So there is a lot of, let's say, the workflows of the flows that are about responding to what's there in the game and fleshing it up. That said, there is also this other side of audio is something that's very good for delivering emotional context, emotional instruction to the players, especially music, but also the sound design. So the context of the game, the larger story, the kind of atmosphere that we want to build, what things can we do on our side, what kind of mixing effects can we apply, or especially with the music, how can we orchestrate this? Obviously orchestrating both in terms of the composers are going to write the music and record it with an orchestra as much as they
like literal
can.
orchestration.
Yeah, a little orchestration.
Okay.
But also in terms of, okay, now we have all of these interactive sections of music, how will we play them back in such a way that will create this narrative? What can we do to create some organic arcs in here to tell some narrative, even in those, let's say, seemingly random, disparate moments? How can we start to tie everything together? Some of it would be like in the ambient sounds, we will often be putting sounds into the world which they fit the mood, they fit the atmosphere, but there's not something perhaps specific that they're responding to. There's not something that's like definitely says, okay, now you have to play here. And maybe a good comparison of this would be, if we think about the sound of adverts in Cyberpunk, we have TVs throughout the world, and the TVs have adverts playing on them, and so when the adverts play, they need to play sound.
Hey, you there? Yes, I'm talking to you. Are you getting what you want?
This is obviously the clear case where the audio is going to fit the visuals. Yeah, it's going to be what we might call diegetic in the world sound. We can then have on the other side, maybe in the music, some themes, and this is score music, and this we would call non-diegetic. So this is purely emotional sound. You could have some sound effects sometimes used like this, but a lot of this will be music that is used to influence the emotions of the player. And this is very cinematic approach. Yeah, it's like in cinema we use this kind of sound all of the time.
Right.
And then there's this ground in the middle where you have the sounds of adverts, but you have them where there's no TVs. So when you're walking through the streets of Night City, you actually often hear these adverts coming, bouncing off the walls. And this is part of creating the atmosphere, part of creating vibe. But actually, this is just the sound designers have gone through, and they've used some technology that we've created to make it easy to have this like dense feeling of adverts. But it's not that there's specific adverts that are being played. It's these have been crafted to create this emotion. And maybe in some districts, it's going to play the sounds that are more glitchy because this is a more run-down district. And maybe in a different district, it will be playing adverts for more high-end gear, and you'll have the more polished sound. And this is something that the sound designers are just doing, right? They're just putting into here saying, okay, we understand what the emotion, the environmental narrative is in this area, and then what can we do to put this in? When we are creating like crowds of Waller sounds, so Waller is a sound of people talking where you can't
Can't actually tell what they're saying. Yeah.
And the name sounds funny, and actually it's interesting because it's different in different languages. I think in Japanese it's like gaba gaba gaba, and it comes from the film side of audio. Actually, it was when they wanted this kind of sound right at the side of a crowd, they just had people saying walla 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 walla. And when you have all of those people talking over, it all merges together, and you can't make the distinct voices. And so when we're doing this, this is not synchronized to the actual NPCs or the characters. And usually we will have the sound of more people, more characters than we have actual people. You know, we're not like counting the number of people and saying exactly this. We do count the number of people, of NPCs, because we generally want to increase it. So if we have like a bunch of NPCs over there, then we will increase it more. But probably we'll use the sound to give this feeling of it being busier than it actually is.
Right, that there's more that you can't see that are
exactly. All of these things. Because all of the games is like smoke and mirrors, yeah? Like this is like the most effective thing you can do is understand what you're presenting to the player and then be very clever about how you're doing it. No, we're not trying to simulate a world. It's not actually the Matrix that we're creating. Yeah, it's
just the illusion of it.
Just the illusion. It is about creating those emotions and portraying that. And I think this is very interesting for us as programmers as well, because we're working very closely with the sound team. So typically what we see from working in audio programming, definitely, but I think in all game programming, where you have this dynamic, yes, you're working on technology, but you also have this creative aspect in mind. You're also trying to think, how is my technology serving the creative goals of the project? On this hazy line, maybe even between where the creativity ends and the technology begins, it becomes intertwined. Games is the collision, the meeting point of technology and art, and yeah, for me that's like one of the really interesting things about it. Yeah, one interesting place to spend time.
Yeah, absolutely. So to go back to the tool set a little bit, just to kind of paint this full picture of like how many different pieces of software there are all involved in day-to-day operations.
Yeah. So we can also talk about how we manage our assets, how we choreograph all of our builds. So we have our own build system that we've created, and now this incorporates also Horde, at least for the Unreal projects.
Oh, so you have actually integrated it with Horde specifically?
Yeah, we use Horde for the UBA. So the UBA is really, really powerful build distribution tool. We've had really great experience with it. It's very fast, very solid. And this has also gone hand in hand with us moving into the cloud for our builds. We have our builds split now between on-prem and cloud to get this acceleration. And we're taking a lot of care to try and not spend too much money in the cloud, because I spoke with many...
That's always the challenge with the cloud,
many developers who had some experiences with that. But so far it's been pretty good. I think our DevOps team and our IT team have been really smart about the way that they've implemented it, the way to use those cloud resources. And we do see the good acceleration coming from there. And so this is our own CI/CD solution that we built for Cyberpunk and now brought across to our new projects. And this includes some tools that like gather together various different tools. So if someone wants a build, we have a tool called Toolkit, which is a place you can see the status of the builds. You can grab the packages. You can maybe install into a console. You can get a save from our SaveDB, which is another tool that we built, so a database for our saves as people are playing through the game. It's logging off these saves, so you can say, okay, I want a save at this part in the quest with these parameters, like I don't know, female V, this quest with this build. What saves are there that exist? And it'll find out from all the people who are playing, okay, here's this save, and then you can say, okay, I want to launch this save on the console, boom, 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 boom. You can automate a lot of this. So I think having this one tool, something actually iterated over years. There was a tool called Red Launcher, I think, back in the day, and then there was another thing called Red Launcher, which is actually the thing that our players have when they launch their games on PC. And then,
right, okay.
Yeah. It was somehow similar, right? It was a way that you could launch builds or maybe DCZ tools and stuff from a single place, have some single configuration. Like, it's important if we have a lot of people using like Maya or Motion Builder, and if they all have like different settings or different setups or different versions, then this can become really hard to manage. You can like something's not working. Why is it not working? Did they do every step that was listed on some obscure confluence somewhere? Yeah, maybe not. It's hard to do. So we have one place that can standardize that and make it easy for people to access this or to run the game or grab different builds. This is another one of those tools that we built up there. And then, of course, we're using Perforce for our asset storage. We also use Git, actually, not for the game code, but for our DevOps code, so asset pipelines.
Okay, like your internal tools.
Yeah, some of the internal tools. When we think about like game code and game assets, like places where we have binary stuff, then there's perforce behind that. Although sometimes now people have less and less exposure directly to the perforce interface because some of that can be done from within Unreal Engine, or Wise has its own integrations, so you don't have to go to the tool to do things, or we have maybe our own tools where we have a CL tracker tool which can be used to submit or run tests or track things.
Kind of like your own version of Unreal GameSync.
Yeah, actually, the version that we have on, because again, we have these different projects here, so the stuff that's running on the back end of CP is quite different from what's running on Unreal, but the front end's the same. We have this one tool that can serve both of these. For Unreal, this is using the back end of UGS, of Unreal GameSync. It's just presenting it as part of this one tool. Try and unify things and tidy things up so there's not so many places that people have to look to do the thing that they want to do. I think this is a worthwhile thing in terms of streamlining those workflows.
Yeah, I feel like since we're all using so many different tools now, like anything we can do pipeline-wise to minimize that, to keep it from being yet another 5 tools you have to learn. Submit this here, go over here to update someone, put it on network storage, update it in a different database. All of that just to streamline, make it less human error, I think, and also more enjoyable for humans to work with.
Yeah, exactly. It's a little bit similar to what we were doing with the procedural footsteps. Obviously, very different problem space, but we really want people to be spending their time being creative and solving technical problems or creative problems, not trying to find the documentation for the specific command line that needs to run this one piece of software, or like update to the right version of this, or learn yet another interface. This is not something that's really pushing our game forward.
Let's move on to talking about the kind of challenge that you had to overcome when it came to getting all of the audio into Cyberpunk. So we talked about this a little bit beforehand, but when you have a world that has so many different things in it, like the TVs with the adverts on them, as well as radios, there's your own personal radios in your car and on your person versus all the ones out in the world. Maybe start by describing what is the challenge that you ran into with that.
Yeah, so we can break this down into maybe a couple of sides of the challenge. Because the first one would be, like, how do we actually create all of this audio? How do we actually author so much? If we think about, for example, like the voiceovers, we localize into, I think at launch it was like 11, or shortly after launch it was 11 VO languages. Each language has 90,000 lines now of dialogue, so it's probably 1 million lines of dialogue across all localized languages.
That's wild.
A huge number of assets. And when we were doing this on Witcher 3, this was actually all of this was handled just by network drives. So people were copying files manually into folders, and of course we had the expert team of localization, but there were times where someone copied a language into the wrong folder, and now half of English is Japanese, and someone has to go through because there's no versioning on that
on the network store.
Yeah, some hairy situations there. And then on Cyberpunk, our approach to try and improve this was to put a lot of this through Perforce. In some ways it worked, right? It gave us a lot of control over the versions and tracking and automating the pipelines, but we weren't prepared for the volume of the assets. So this is submitted in Perforce now, but
millions of files.
Yeah, millions of files, and then every version of those millions of files sitting somewhere. And whenever we made a change, sometimes we were making changes that was like, okay, let's change the way we normalize the files. That's all of the files get redone. Every single file.
That makes sense.
So, and not just those million files, but different stages of those files. So the way we did it, we had the raw file, the processed file, and then we had the mastered file. Some of those could then have additional processing done by the sound designers. So you had all of these different stages, which was kind of useful for us to access and say, okay, what was the file like at this stage, because we're not sure what was going on there, or we want to do a custom version. But it became kind of tangled to do, and it's at the point where you cannot download this folder yet. If anyone downloads this is annihilation for any SSD that's
for their hard drive.
Maybe the newer ones are bigger. You have a 4 terabyte SSD.
When we talked about this beforehand, I've been on a big kick lately of trying to teach more people about virtual streams in Perforce. It's like that's the perfect use case there, where you could have this depot, this mainstream that has terabytes of files on it. But if each individual person only needs maybe the one region that they're working on plus a few shared files, I think that's such a good example of how you can do that. And each person can pull what they need, and they don't have to have all of that.
Yeah, and we see this paradigm push to remote work, and there's more people working remote. Even after COVID now, we still have a lot of people work remote, and the internet connections. In the office we have 10 gig, so it's like downloading anything is pretty fast. okay, you can make something that's big enough to download slow, but I know I have an audio coder working from Italy or another coder working in Ireland. If you're downloading over the internet there, some very big package or all of the assets, it can be a lot. So we see this in Unreal Engine now with the virtual assets. It can be like a huge win for those people in terms of speeding up the workflows, or sometimes we're having workflows like, okay, mostly they will work on a computer they have in their room, but there's an option to dial into a shared computer on site to do some stuff and deploy a build to a console that's also on site, and then those processes can be like blinding fast by comparison. I mean, it's a different of hours of iteration time difference, not cumulative, like each operation. Yeah,
when you're at that volume of content, for sure.
So this is one side of it, like dealing with generating that amount of content. Part of it is just like the pure doggedness and hard work of the sound designers to build this much content, of the composers to write and record this much music. I think it helps a lot that we have the large in-house team on both sides. It's not that normal, I think, in the industry to have, for example, a team of composers in-house, but we do have...
Right, yeah, I don't feel like I see that very often.
We have it in-house, and we also do some outsource as well, but having that constant team, that means that we can do quite a lot over the lifetime of the game. We can be iterating from the beginning and have the opportunity to generate a lot. The second part is, like you're saying, when we're in the game, how then do we deal with all of these sounds that need to be played, especially in somewhere like Night City, or almost everything that can be there can make a sound, potentially, and there's only so many resources to play them. But also, we want to take a kind of... I mentioned the word cinematic before, and I think this is really relevant because it's quite mature discipline, audio in cinema, in terms of understanding like what people can hear and make sense of, and how to use this creatively. So if we just play all of the sounds all of the time, actually you won't hear all of the sounds anyway. This is the nature of sound. It has masking. It will do that. Maybe it will even be like slightly more messy because we don't have the full dynamic range of natural sound that we're shipping with, so everything's like slightly compressed, even if we're not like heavily compressing our assets. We want kind of clean sound there. It's still not the same as you have in the world. So you don't want to play everything. So it means that you then need to start to choose which things to play and which things not to play. Even with this, we want generally to have a large amount of sounds. I think, I know whenever I talk with Audio Kinetic and I say, oh, we're having some problems with this many sounds, they're like, why are you doing so many sounds? No one does this many sounds. Okay. We just go that way, I guess.
Well, you want to create the whole world. That's kind of CD Projekt's whole thing, right? Is creating these big worlds, and so
all of the world and all of the detail with all of these layers, and this does start to add up. You know, even if you're doing cinematic combined sounds like the Waller or ambient sounds, it's like a quad. So let's imagine you have like a quad of ambience, and you want the quad so that as the player turns, you have this bed of ambience and it rotates around the player. You get this sensation of movement, even though it's not real diegetic things in the world. It's still relevant to the world, and you want to feel like it's tied to the world. So if we think about it before, maybe like Witcher 3, before we started working on audio code, and I joined in 2015 as the first audio coder there. So before this, maybe you would have a stereo sound for the ambience and then some spots in the world. A traditional way to do things, I think it's quite good. You can have this cinematic feeling and from the spots, rather than just the stereo bed being static, actually having it rotate around the player ties in this immersion much more. Gives this cinematic design and interactive connection that's very powerful. So so you have a quad bed for things, but maybe you want this to be dynamically shifting based on the number of people you have in some direction or objects.
Sure.
2 or 3 of those quad beds. Okay, now this is started to multiply and have some more, and maybe you want some different variations of those. And so you can see how these things, just for that, starts to amplify. You have your Waller, your wind, maybe some traffic noise, maybe some different kinds of weather sounds. Starts to add up. So we needed to handle the impact of really 3 things if we want to have this kind of dense experience. We need to be able to handle the CPU load, the memory, and then the streaming. So the streaming and the memory go hand in hand. In order to do this, we built some custom systems around the streaming that meant we were able to go from, in Witcher 3, a case where we used a traditional approach, the sound bank approach, where you're in some area and you say, okay, let's load in all of the sounds related to this area, or we're in this quest, let's load in all of the sounds for this quest so that they're in memory. We can have them obviously compressed in memory. We don't have the raw PCM. This is too big. But this requires a lot of work from the sound designers. They need to organize their sounds into these blocks so that they can be loaded in. And then at runtime, You have to be careful about how you're loading the blocks because it obviously takes more and more memory the more things you have. And if you have the open world game, then it's very easy to start creating situations where, okay, I have all of the quests open and I'm running between areas and then do a fast travel, and all of this stuff can start to stack up. So in Cyberpunk, what I think is becoming more popular now, for example, in Unreal Audio, just take the same approach of, okay, we will basically stream everything. We will have everything streaming off the disk, which means that the very low memory hit by default, right? Because you will only have in memory really the sounds that are playing. If you compare this to before, it's a tiny fraction of what you would have in memory from sound banks if you're streaming. However, then you hit this next problem, right? The streaming impact that you're gonna have, because we were always streaming large files like music, maybe some ambience. Just having them in memory was too much. But we, of course, have to share this streaming with other systems and with the rest of the game to come in.
And what would you say are the main competitors for that streaming? Is it textures mostly that you're competing with in audio, or?
So the thing about audio streaming is that when you want it, you need it fast. Any disruption in the audio is felt very keenly. If you have a cutout or glitch at some point, it's very, very obvious. More obvious than a small glitch in audio is very obvious compared with a small glitch in graphics. Of course, it's not that you want to have glitches in graphics, but typically we're more comfortable with it probably because we blink. So our whole lives, we're used to having these very short disruptions of the visual process. It's why you can very comfortably have a camera jump between locations, and it's not really a problem. Even a very small disruption in the audio, however, from the moment we're born, in fact, probably even from before we're born, we never have a single discontinuity in audio, right? It's like just constant. There's no eyelids on audio. Maybe if you go into an sensory deprivation chamber, you can start to have this weird experience and start to hallucinate because...
And that's probably why, because we've never experienced it.
Our brains just aren't used to having that. So we have to be very careful about it. And that means that when you need audio, you need to have it very quickly. Especially if you're streaming something like VO, like some audio, you can at least have some delay, right? You could wait a little bit. If it's ambient audio...
I imagine music could have a little delay.
Yeah, if it's like that, about when you're going to start the ambience, or most of the time when you're going to start the music has to be strongly on the beat, but you can get like quite a chunk of it up front. But if we think about a VO, a voice, if it's slightly out of sync with the lips, you feel it very keenly, very sharp to the senses. So from this point of view, we're going to have high priority on the audio streaming most of the time. And we did make some distinct differences between if we were in the heavy streaming situation. So let's say we're just driving through the world. So this is like the worst case for streaming. The very worst case for streaming in Cyberpunk is you're driving and having a conversation at the same time, because it means you're driving through the world. It means that you're streaming the textures in, but worse than the textures not streaming in, if the physics doesn't stream in, you'll fall through the world. If the gameplay doesn't stream in, then anything can start breaking. And streaming is one of those cases where when it goes wrong, when stuff starts coming late, too late, you say, there's like some tolerance it can have, but after something, it just falls off a cliff, and anything can happen at that point. It could be T-posers, it could be blob faces, it could be the game crashing, it could be getting stuck in some infinite loop, or like, who knows, like all bets are off if this goes too much to pot. So we had to put some work in to cache things up front, so that things which really needed to be there as soon as possible. When we're in the cutscenes, we're looking ahead through the cutscene, and we already start streaming the voice lines before you get to the voice lines. So as soon as we see this scene coming, we procedurally just start to load those. When the player loads their weapon up, then we say, okay, any sound that can be triggered from this weapon, let's just pull those in, start to pull them. When you get in a car, we're loading all of the collision sounds. It was quite common during development that you'd be driving along, and because it's such a streaming intensive at a time, it builds up a long queue of things you've streamed, you would crash something, crash sound. Like sometimes like, it would come in.
I would imagine we'll start with the weapon thing you were talking about. I'd imagine that you're also having to procedurally check for all the weapons around, because you wouldn't want to not hear gunfire from nearby.
Yeah, so whenever anyone's equipping the weapon, we can load this in. There's a little more tolerance on the NPC sounds, because they're not as diverse as the player sounds.
Right.
So we can be a little more tolerant there. But especially if someone presses a button, they experience fire. If an NPC has to wait a fraction of a second before they shoot, because it's waiting for the audio to load in, Generally, that's okay for the gameplay. There's maybe some
Right. That makes
specific
sense.
cases where it needs to be already there, but you can do this preload manually. But most of the times, the player needs to have this very responsive thing. There's different cases that you have, not in Cyberpunk, because it's single player, but if you have the multiplayer game, there's a middle situation that you can have with other players' weapon sounds. Because typically, the local player, the client, is going to have the priority and the most important sounds, the biggest sounds. But actually, other players, in this case, if it's competitive especially, it's very important that you hear them. Because if you don't hear a sound and then you die, you're like, well, what happened?
Yeah.
I didn't have a chance to dodge. I didn't know what it was happening. I didn't have this feeling. So in this case, also, they need to be very acutely measured. So to help with this, we built a custom streaming system. It was built on top of Wise. And to the sound designers, it looks like everything is streamed. And actually, to them, it looks like everything is streamed PCM data, so uncompressed. This was to help us also with the CPU side of it. We had a part of the pipeline, after the sound designers had done their work, that would take all the files and compress them to Opus, which is a slightly more expensive codec for audio compared with, for example, Vorbis, which is like very common. It actually uses partly Vorbis in its compression, but it's very effective for speech.
And is that, you said it's more expensive, but still affordable, I guess we could say.
So I'll get to this part. I'll get to this. There was a reason that we went there, and a slight hint towards that is that the consoles of this generation, so the PS5, the Xbox Series, they typically will be using Opus for their sounds. Maybe not all the sounds, but a lot of the sounds. And on Switch as well, actually.
Okay.
Which actually I just bought my Switch too, so I can play Cyberpunk on it. And
Nice.
so the advantage of Opus is very high quality. So if you compare like to like, Vorbis is very good, but there's an extra clarity even when you compress quite heavily. The Opus is very resistant to losing quality at low bit rates. So you can squeeze the files down more and more, which then helps with the memory. Potentially with the streaming, if you do this one cool trick that I mentioned, because the thing with the sound files is that we have some sound files that are big, like a track of music. This is big enough that we all want to only stream parts of it at a time. But many of the sound files are going to be way smaller when compressed, like a few K, maybe like tens of K, something like this.
Right.
And if you stream individually each of those, you're starting to lose some of that bandwidth from the streaming, because there's a minimum size. On SSDs, it's for sure smaller, but on the hard disks, which we shipped Cyberpunk originally on the previous gen, PS4 and Xbox One, if you seek to the audio portion of the disk when you have the spinning disk, there's a huge cost to do this, and if you go in there and taking like a few K, and then coming
back and forth,
this sucks. This is no way to optimize the bandwidth. So what we did was, after the sound designers had done the stuff, we took the loose files and we packed them together based on the order of the events in Wise. So depending how the sound designers are structured, by whatever organization they thought of, we would group them together and put them into 1 meg blocks. So we would make 1 meg, we call them Opus packs. So it's like a 1 meg-ish block of Opus data. And then this is what we streamed in. The idea here is that whenever we do a stream for audio, we would pull in not just one file, but we'd pull in that file and then approximately 1 meg of data that surrounds this file. And because this was very likely the other files from the event, or other files that maybe would be triggered the next time that someone shoots the same weapon, maybe it's going to choose a different random sound from this thing, we would already just have them cached in memory. And so we put a very large cache, like 40 meg cache, just for holding these blocks. So we're constantly streaming them in and out, but we're very often taking from the cache instead of having to stream from the disk. And so this is where we start to get some optimization for the streaming, because it means that we can be playing many sounds, but if it's something we played recently, maybe, and it worked like for materials as well, if you walk on a certain material, now you have all of the sounds for that material in memory, and if you're working on a material, very likely that you're going to have some other sounds related to that to that material, and they will just happen to be in memory.
What's jumping out to me is that by basing this off of how the sound designers organize their projects, it's almost as if you set up a procedural way of grouping these. So like rather than saying, oh, we had to come up with the system and figure out what would be together, you're just like, you know what? People already were doing this. Let's just leverage the organization they already used and then take advantage of that in the game.
Exactly.
Like that to me is very cool to think about that procedural approach to pipeline in a way.
Yeah, it's probably worth to say that this is not the optimal way to load sounds. If you really wanted to be optimal about it, then you would have discrete chunks that were exactly what needs to be loaded. I know if you have a very deterministic linear game, then you could do it like this, where you go, I know exactly what's needed in memory. I will load exactly the things that I need in memory at this time, and this would get you the smallest possible size. But the idea is it doesn't have to be perfect if it's good enough to get the job done. And so we want to have that balance of workflow and efficiency that we'll get in there. And for us, it was a tight squeeze for sure, especially on the previous gen, to get it in. But if we compare like Witcher 3 with Cyberpunk, we reduced the amount of audio memory we were using between Witcher 3 and Cyberpunk, despite the fact that Cyberpunk is a much bigger game. Yeah, it's denser. Right. You know, the amount of sounds, I think it's probably like double the amount of dialogue and 4 times the amount of music, and generally the denser world. Yeah, so many things going on in this.
More playing at once.
Yeah, certainly more than once play at once. So more materials, more weapons. You have guns, you have vehicles, you have all of these different vehicles, you have all of these things. So we have, like, the much denser world and use cases, but still we managed to shrink that by, I think it was like 30 megs or something. This is like 15% reduction in the size of memory. And at the same time, this was now including on Cyberpunk the acoustic graph that we added, so the procedural acoustics. It was including the localization, all of the code structures which didn't used to be included as part of that number. So memory-wise, a huge win for us, and memory was very tight to manage to get that in. Without it, this would have been really, really tough to make happen. But then we get to the CPU part that you mentioned as well.
Yeah.
So we have all of this Opus data in memory, and we have the call from Wise. Well, sound designers in Wise set it up to be PCM. Wise is asking for PCM data. Now, normally you would give it the compressed data and Wise would handle the compression. But what we did was that we did the compression ourselves after Wise had done his part of the pipeline, and then we did the decoding ourselves of the Opus. And what this meant that instead of doing the decoding inline on the normal Wise job, which is very time sensitive, as I mentioned, like audio has to be streamed and especially processed very regularly, or you'll get the clicks, you'll get the cuts and the disruptions. We decoded it ourselves, but we decoded it async, so off the Wise job, and actually used a separate core that the rest of the game wasn't really using. There's a core that is, let's say, shared with the system, and so it's not typically used for real-time work. You can't put audio on it. Actually, well, when I first came to CD PROJEKT, audio was running on this core, and then when we did the Wise update, all of the audio broke, because you're not allowed to have audio run on this core because of the... I discovered the hard way when I broke all of the audio in the game by updating. It was only on the console. That was a lesson learned.
But so you can't run audio on that core, but you can run compression, decompression.
Yes, you can't run the Wise update on this core because it's not reliable enough to do this. But actually, because the audio needs to be continuous, it can often tolerate latency. So if you're already tolerating some latency for streaming it in, maybe you can tolerate a little extra latency to do the decode. Because of this, it meant that we could do the Opus away from the game and have this higher quality audio. Again, even on the previous gen, where this was not very commonly used level of quality of audio because of the CPU cost, we were able to do this. And this helped us then get the memory down, because you can compress it more while having the higher quality. So this was part of our strategy. In addition, because we took control of doing the decoding, it meant that we could then take advantage of the streaming cache in Wise. So the same way that we were caching our streaming, Wise does this natively. It has its own stream cache to do exactly the same thing, for exactly the same reasons. But now, in this situation, the streaming cache in Wise is the PCM cache.
Right.
So the decompressed audio, much bigger than the normal streaming cache, so we have to give it a healthy chunk, another 40 megs of memory to be meaningful. But because it's now caching the uncompressed data, it means if we have the same sound played on repeat, we will only pay the decode once for this. So when we have those physics sounds that are playing around, or some machine gun, or
Right.
something like this, we don't pay the cost for every sound, only this one sound, and then the PCM cache will be getting hit in WISE. So this also is then saving on the CPU cost. In specific situations, yes, so it's not every situation that it saves it, but this is how
Right.
you do it, right? You chip away at those things until you're happy.
Do you feel that because Opus and these codecs are becoming more common, that's going to be built into more of the silicon on chips
This is
so that
yeah.
is faster to do real time?
This is exactly why they're becoming more common, because on the modern consoles they have hardware for decoding Opus. So we were maybe a little ahead of the wave there, but now you have hardware for Opus, and I think this was the response to the strong voices from game devs saying we really want to have Opus decoding. Whenever people would ask, okay, what audio features do you want the sound design? I would go, we want Opus decoding so we can have this higher quality assets, because, you know, it's nice to have cool, flashy new features, but often the thing that you really need is just being able to do that basic thing better. Yeah, just raising the quality of the most basic thing can have this very wide effect. And we did do A/B tests in Cyberpunk. Even when we came back to Phantom Liberty, we wanted to check again and say, okay, it's been a while since we were running in Opus. Like, how does it compare with Vorbis? And so we made a version which was using Og Vorbis rather than Og Opus, and we compared them, especially in those dense fight scenes when you have lots going on. It's not like Vorbis is like crackling or very heavily distorted.
Right, not that bad.
It was quite good itself. I recommend it. With the music we actually do in Vorbis, it's maybe a little technical detail, but under the hood, Opus is like a combination of Vorbis plus Silk, the voice codec, and this is where it gets its efficiency by combining like taking the sound and half decoding it in these two, and ordered sound like music might as well just be done with Vorbis. There's not really advantage for putting it into
It's
Opus.
not taking advantage of the
No,
volume.
you don't get extra compression like you do with sound design, or especially with voices. If you compress voice, Opus is very effective at that.
And that's why Discord uses Opus now. Voice chat is all Opus.
Yeah. So you get the great compression and the great quality. It's like win-win. Add some CPU cost, but for something like Discord, I think the CPU cost is not.
Right. You're only streaming a few channels at once.
Yeah. It's not trying to do like a couple hundred voices.
Yeah,
Well, maybe
not
there
the
are
same.
cases where you do it, but even so, it's probably not okay to have that. I don't know. Maybe there's some cases. I've not come across them in my personal Discord use, at least.
Right. Me neither.
But the clarity was clear. You can just hear more detail in all of that sound. It means that if you're going to make that choice, everything will sound better. Right? The whole game, the whole audio.
Right.
And it's not something that someone's going to point at and say, "Oh yes, this was definitely this codec's being used because I can hear that."
Yeah.
No, it doesn't work like this. It will just be overall better quality that the people will experience.
Yeah, absolutely. I think that's always one of the funny things with audio is maybe because it's always going on in our heads all the time, we can't turn it off. It's something that I think compared to visuals, we take for granted most of the time. Like it has a big effect on us, but we're not as able to identify why it is that we're having more of a reaction or why it is that we find this harder to navigate, unless we are maybe someone like you who's really tuned into audio and like you know what to listen for and you know what you're trying to get, right? To get that feeling of both immersion, but also the emotional impact that you want.
Yeah. I mean, even for me, honestly, like this would be hard for me to check without the A/B. If someone presented me like a call and said, "Is this Opus or is this Vorbis?" I wouldn't do it. If you give me both of them, I will tell you which one is better.
Yeah.
What we showed in this experiment that we did wasn't only the people who, let's say, had a lot of experience working with those things. Everyone could notice the difference. Like anyone we showed it to was like, yeah, this one clearly sounds better than the other one. So it's not just something nice for the sound designers to have. It does have this genuine impact and effect for the players too.
I want to take a moment to give a shout out to people that are newer in the industry or who are wanting to get into it. And I'm curious for you as an experienced pro, what workflow essentials would you prioritize for small teams or indie developers that have limited resources? They might think, oh gosh, there's no way we could do all these custom tools and custom CI/CD build stuff. What would you find are like the one or two things that would be the biggest impact if you're kind of low on resources like that?
So I have a little experience with this now with my side projects. I'm composing for indie games, and I get to see, let's say, both sides of the industry, both some of the biggest games being worked on where it's at scale with huge teams, and also the very, very small team, scrappy little team trying to make the most of everything. I think there's maybe it's a bit of a soundbite, but I think there's not been a better time from the creative perspective, the industry, in terms of jumping into the industry. Right now, there's certainly challenges, like getting investment, things like this is certainly something that we struggle with. But in terms of the workflows and the creative power, you can download Unreal Engine and you'll be using many of the same tools that we use at CD Projekt, because that's the engine that we're using to make Witcher 4.
They're all built into the engine, yeah.
And even, the collaboration we've done with Epic on the Witcher 4 tech demo, from there, the pipelines, the streaming, the foliage, the animation stuff, this is all going back to Unreal 2. So you have at your fingertips incredibly powerful technology, and we see a lot of work being done to make it easier to get that high quality. Also in the keynote, there was this demonstration from the MetaHuman. They had the webcam, so Xanadu Blue was performing live on stage, the webcam converting his expressions, performance capture, live into the, I guess you can say it's a VTuber now.
Right.
It looks the same as the stuff that he was doing when he was captured and done offline, at least in my eyes. These are very powerful tools that you can have access to. I really recently was impressed by Claire Obscure, Expedition 33. I'm playing through this.
Yeah.
I haven't finished it yet, no spoilers, but
I'm just about to start it. So
okay.
yeah.
I also won't throw any spoilers there. But I think this is a great example of a team that's for sure on the smaller side, and using like every ounce of possibility from the tools that are there. Using the assets from the marketplace. And in the interviews they were talking about using the free assets and making use of those, having the really solid creative vision of what they want, an artistic vision, and then also a weird world where they can experiment and go wild, but it all feels pulled together because of that clear artistic theme. And generally, I think they just made great use of the tools that were there. They only had a few programmers. I think by the end, 4 programmers. So it's not like they were redesigning workflows. It's not like they were re-implementing whole tool pipelines. But from what I gather, from what I read from them, they really had this focus of, okay, what can it do well? Let's use that.
Let's lean into those things.
Yeah, and lean into it, exactly. Yeah. And the game is fantastic. I find it a real inspiration, to be honest, to see the team is squeezing so much juice out of what's there. And I think everyone can have this approach to that. You can just go and download Unreal Engine for free. But I think it is cool what they've done there. You don't pay anything until you've made $1 million. That would be cool to get to that.
Right, yeah. If your indie game hits $1 million, yeah. Great. Good for you.
Yeah, I'll be glad when my side project reaches that milestone of having to pay.
Exactly. One last thing I wanted to check is, if you were to travel back in time to yourself at the beginning of the challenge that we talked about, right, where you're trying to figure out how are we going to stream all this in, how are we going to manage all this, is there anything that you'd say, go about this differently? Do you feel like you learned anything from this that wasn't just the solution, but kind of an approach or a mindset?
Yeah, there's probably some technical details that I would go into. I would maybe like to have from the beginning some automated testing, especially when we think about the container system, the streaming system we did. It is complex. It is hard to understand, and not just everyone can go in and fix bugs with it. So having some thorough automated testing from the beginning, and even going over content files and checking this parity between what we expect, what we have, I think. And maybe I could point some specific things to myself about, okay, you need to use some atomics in this place and not this place. Be aware of how this thread is going to work. Or here's these calls back from wires, you should use these ones in this location. All of this kind of small technical detail. But I think the approach I'm pretty happy with. Maybe slightly different in the future. We live in a different world now with the SSDs. I think it probably wasn't an option, but if it was possible to go back and put SSDs in every console like a generation ago,
right.
then
right.
For sure that would have made my life easier. And that takes some powers beyond time travel, I think. Maybe I travel back even further and then start investing in the stock market at the beginning, and then by the time that I can afford to know.
There you go. I mean, once we start doing time travel, why not go all the way? Yeah. Well, thank you so much for taking the time today to share your experience and share what's been going on with this. I'm super excited to check out Witcher 4, obviously, when that finally drops. I don't know. I don't have a date yet, but I'm excited for it. And of course, I want to go back and check out Cyberpunk and listen to more of these audio things that you're talking about and kind of get more of a sense for that. So thank you so much for joining us, Colin.
My pleasure. It's been great.